Hey everyone, and welcome. Today, we're going way beyond just talking about a simple chatbot. We're going to piece together the entire modern AI stack. We'll look at how you can take a brilliant AI brain and turn it into a powerful, capable system that actually understands your data.
You've probably felt this, right? You see these mind-blowing AI demos, but then you try to use it for a simple, practical task at work, like, hey, can you summarize this report from this morning? And it just hits a wall. It has no clue what you're talking about. So how can this incredibly powerful tool write a perfect poem, but not read a simple PDF? That's the exact puzzle we're going to solve today.
The answer to that puzzle starts at the very core of the system, the brain itself. And you know what? As brilliant as this brain is, it has one very specific and very big limitation.
That brain is a large language model, or LLM for short. Now, at its heart, it's a super complex neural network that's been trained to do one thing and do it incredibly well: predict the next word in a sentence. But, and this is the big but, its knowledge is literally frozen in time. It only knows what it learned up to its training cutoff date. Anything new, like your company's report from this morning, basically doesn't exist in its universe.
I love this analogy. It's perfect. Think of the LLM as this world-class consultant. I mean, they've read 10,000 books, so they have this massive wealth of general knowledge. But if you walk into their office and hand them a new file, they can't just read it on the spot. All their expertise is based purely on what they've already memorized.
So, if our brilliant consultant can't read new files, what do? Well, you don't try to just cram more books into their head. No way. Instead, you give them a personal assistant and a perfectly organized library. And this is the core idea behind a system called RAG.
Without a system like RAG, and that stands for Retrieval Augmented Generation, getting an LLM to learn your private data is a total nightmare. I mean, trying to retrain it or just stuff millions of documents into its little input window is insanely expensive, it's slow, and honestly, it's just not practical for answering real-world business questions.
Okay, so here's how RAG actually works, starting with getting that library set up. First, you gather up all your documents. Then they get broken down into smaller, more manageable pieces or chunks. After that, each little chunk is converted into a numerical representation called an embedding. Now, just think of this as a way to capture the meaning of the text in the language of math. Finally, all these numbers are stored in a special kind of database called a vector database, which is basically our super organized digital filing cabinet.
All right, so the library is organized. Now for part 2, finding the right file. When you ask a question, your question also gets turned into one of those numerical embeddings. The system then instantly searches that vector database to find the document chunks that have the most similar meaning to your question. That's how the most relevant bits of data are found, pulled out, and handed to the LLM along with your original question, all in a nice little package.
So the takeaway here is absolutely crucial. The LLM is the senior expert, the brain. The RAG system? That's the hyper-efficient personal assistant. And the vector database is the filing cabinet. The assistant doesn't bring the engineer the entire cabinet, it just goes and fetches the exact file needed to answer the question at hand. It's smart, it's efficient, and it works.
Okay, we've given our brain a library, which is awesome. But how does the brain itself actually process language and understand context? For that, we need to pop the hood and take a quick peek inside the architecture that really made all of this possible, the transformer.
The transformer is the revolutionary neural network design that underpins pretty much all of modern AI, from ChatGPT to Gemini and everything in between. Its real superpower is understanding the incredibly complex relationships between words in a sentence, which gives it a true grasp of context.
So the secret sauce here is a mechanism called attention. See, older models had to read text word by word, and they'd often forget the beginning of a sentence by the time they got to the end. Transformers look at the entire sentence all at once. So in a sentence like, "The bank near the river flooded," the attention mechanism can weigh the importance of all the words and immediately figure out that the word river is the critical clue to understanding that bank means a riverbank, not a place you put your money. It's brilliant.
And here's the super simplified flow of how it works. Your text gets broken down into tokens, which are then turned into those numerical embeddings we keep talking about. Those numbers pass through the transformer's layers, where that self-attention magic happens. The model gets a really deep understanding of the context, and only then does it make its prediction for what the next word should be.
And this transformer architecture is the foundation for the entire LLM world we live in today.
All the major players really fall into two main camps. You've got your commercial models like OpenAI's GPT and Anthropic's Claude, which are often pushing the absolute limits of performance, and then you have the open source models like Meta's Llama and Mistral, which give developers everywhere incredible power and accessibility.
Okay, so our system now has a brain that understands context and a library for specific knowledge. It can know things, but how do we get it to actually do things? To go from a know-it-all to a do-it-all? Well, that's where AI agents come into the picture.
So an AI agent is basically a system that uses an LLM as its reasoning engine to get a job done. And the key word here is tools. It can interact with the outside world, it can call an API to get live data, it can query a database, it can even write and run some code. Think of it like a single intelligent worker assigned to a very specific job.
Now, agentic AI, that takes things to a whole other level. It's not just one worker anymore, it's a whole team. It's a system where multiple agents work together, on their own, to achieve a much bigger, more complex goal. This involves stuff like planning, collaboration, and making multi-step decisions, just like a human project team would.
Let's just break down those differences really quickly. A single AI agent is focused on executing a task, usually in a pretty straightforward way with limited freedom. But an agentic system, we're talking about a whole team of agents driven by a high-level goal with a ton of autonomy to figure out complex and dynamic problems. That's a pretty big leap.
And hey, if you ever need that perfect quick one-liner to remember this, here you go. An AI agent uses tools to get a task done. Agentic AI is a team of agents that plans and achieves a complex goal all on its own. Simple as that.
This whole vision of an autonomous AI team is incredibly exciting, right? It feels like the future. But it's also really important to ground ourselves in what's actually practical and what's being built and succeeding out in the real world today. And this insight, which comes directly from the creators of the Claude model at Anthropic, is so important. They found that one of the biggest lessons they learned from building these systems is that you shouldn't over-engineer them. So many problems just don't need a complex autonomous agent. The key distinction really comes down to this: a workflow versus an agent. Most successful systems today use controlled workflows. The steps are already defined in the code, so the LLM follows a predictable path. A true agent is dynamic. It decides its own path. And while that's super powerful, it can also be a lot less reliable and way more expensive to run.
So, the big takeaway here is this. Most of the amazing AI products you use today are not these fully autonomous sci-fi agent systems. Not yet, anyway. They're built on the strong foundations we talked about. Really good RAG systems, structured and controlled workflows, and agents that are used for very specific, complex tasks where their dynamic nature is a huge plus, like writing and debugging code.
So, we've covered the brain, the library, and the workers. You now have the fundamental blueprint for a modern, truly capable AI system. The only question left is, now that you know all the building blocks, what would you build?